So in terms of other, faster parts, bigger parts, how do we print metal and plastic together so that it creates a functional part? These are all some of the questions that are being asked right now. We're also looking at how do we use this for new ways of innovation. And so one of the things that GE did was partner with GrabCAD. So now you can, GrabCAD is a repository of online 3D models. So if anybody's heard of Thingiverse is another, you can actually go online and download any part that's out there. So that's pretty cool. So they partnered with GrabCAD and they had an open innovation challenge. They said, here's our bracket that holds our, it's an engine test stand. This is our current bracket. We've machined this away out of a block of aluminum or whatever it was, and it currently weighs about 4.5 pounds. This is obviously the plastic version, so it's a lot lighter than that. But here's the loading condition. Here's the bolt pattern. Give us a better design. And so they opened it up, crowdsourced that, and within about 3 months, they had 700 people submit designs. They then took the best designs, sort of screened them, picked the best 10, gave each one of them $1,000. Not too bad, right? Then they printed those out of metal, tested them, and then they gave the winner $10,000. You'll see, unfortunately, there's no US in the top 10 there. Okay, our design wasn't picked. Any guesses on which one was the winner? The red one? How much is just the look of it influencing you or not, right? Okay, bone, you know? I mean, that's a good-looking picture there. I don't know whether it's a good bracket or not, but all right. Indonesia. Gentleman right there, barely 18, 19 years old. He and his brother had started D-Tech Engineering over in Indonesia. They're $10,000 richer, and apparently GE has hired him as well now. So, not a bad gig. So, his part, 84% lighter than the original one. And so this goes to this buy to fly ratio. GE buys 10 pounds, machines away 6, and flies 4.5. No, we're just going to print it and not even print a full pound of material. So the weight savings, the time savings, the energy savings, huge opportunities here for this. We're doing some work similarly now with space applications, $10,000 per pound to fly a pound up in space. So if they could save 4 or 5 pounds, that's $50,000 right there that they've saved. And that's one component out of the hundreds or thousands that are on a rocket or whatever the case may be.